If you accidentally fall into a black hole, what kind of shocking scene will you see? The truth may overturn your cognition. In fact, the black hole itself is not black, nor is it a hole. In Einstein's general theory of relativity, a black hole is a kind of space-time curvature from which even light cannot escape. And now we will take a spaceship to the black hole and embark on a wonderful journey through it. As the spaceship approaches, we jump out of the cabin, starting to approach the black hole under its gravity. But before that, we must wear a specially designed spacesuit. This is because the mass of the black hole is extremely strong, its gravitational pull equivalent to millions of times the mass of the sun, so much so that all surrounding stars and matter are captured by it, forming a very thick accretion disk. Even more terrifying, they rotate at speeds close to the speed of light. Due to constant friction, the surface temperature of the accretion disk can reach hundreds of millions of degrees Celsius, also producing intense and deadly radiation. If you are not wearing a spacesuit, you will be instantly vaporized. Interestingly, if you filter out all light except visible light in the electromagnetic spectrum, you will find the spectrum shows higher energy blue light in the disk. The black hole photos released by NASA show bright orange, which means they only represent bright colors, not the true colors in visible light. This also explains well why stars with higher temperatures emit strange blue light. Strangely, one side of the accretion disk seems brighter than the other. This is because the matter in the disk moves very fast. The right side is approaching us at high speed, so all light waves are superimposed, making it look brighter. The left side is moving away from us at high speed, stretching the light waves, making it look dimmer. This is the magical Doppler effect. If you observe carefully, you will also find a distortion behind the accretion disk, as if it is folded around the black hole. This is because the strong gravity of the black hole bends the light, like a gravitational lens, so when we look in a certain direction, the position we see is actually lower. At the same time, we will also find the starlight in front seems to be slightly blue. This is because the strong gravity of the black hole warps the surrounding spacetime, making time around us slower than the time of distant stars. From our perspective, the light from the stars accelerates, producing a blue shift. As we approach the black hole, we will see a strange aberration, as if the black hole is moving away from us. This phenomenon is because, although we receive light from the accretion disk from different directions, we are constantly approaching the black hole, so the light in front is constantly shrinking. As we accelerate towards the black hole, the light in front looks brighter, while the light behind becomes harder to reach us, thus becoming darker. This is also a phenomenon caused by the Doppler effect. If you observe the spaceship in orbit at this moment, you will be surprised to find the clock inside the spaceship runs slower than before. This is because the signals sent by the spaceship every second take longer to be received. Next, we pass through the accretion disk. At this moment, the disk gradually disappears from our view as gravity increases. All matter here becomes unstable, orbiting the black hole, starting to accelerate and being sucked into the black hole. About 2 minutes later, we reach the vicinity of the black hole's photon sphere. In this area, any light from outside is destined to fall into the black hole. As we get closer to the black hole, people on the spaceship far away see our image gradually fading and slowing down until it disappears from view. In the next few seconds, we enter the photon sphere, reaching the event horizon of the black hole. From this moment on, the outside world will forever become our past. Everything about us will have no connection with this universe. Even if you send a signal to the outside world, the signal cannot escape the black hole to reach its destination. So what will we see after passing through the black hole? In fact, at this moment, we can still receive light from the universe, even seeing the spaceship outside the black hole. So we may not even realize we have crossed the event horizon. Although on a large scale, the gravity of the black hole is enough to isolate its interior from the exterior, on a local scale, spacetime is almost completely flat, and the curvature is not obvious. So we will not feel the changes brought by spacetime curvature. And due to the strange aberration, even though we are inside the black hole, our view will not be completely dark. On the contrary, the image of the black hole only occupies 15% of the front view. In the surrounding area of the black hole, we can still see the scene of the starry sky. In the following time, our speed of falling into the center of the black hole will increase, even the light behind us seems to be in front of our view. As the front view shrinks, the rear view will become wider. The spaceship far outside the black hole also becomes larger in view, even though we are getting farther from it. At the moment we reach the center of the black hole, you will feel an incredible strong force tearing your body. In the last moment of our consciousness, you will feel like you have fallen into a dark, flat surface. In the next 0.1 seconds, our body and consciousness will be completely shattered, entering the center of the black hole. For us, this black hole journey ends here. But for the spaceship outside the black hole, we will live forever in the event horizon. In fact, including modern physics, we still cannot explain what happens when falling into a black hole. But current theories suggest the center of the black hole is a point where space-time curvature is infinite. Of course, some scientists question whether the singularity actually exists. Perhaps only when we unify gravity and quantum mechanics will we completely unravel the ultimate mystery within.